I'm an Android developer. Have been since 2012. Worked with all parts of the Android ecosystem, from custom ROMs to Android Wear and tablets. You name it, I've at least tried to do something with it. And of course, being the developer in the family, I also have to help my wife with managing her site, the technical part, and keeping everything running smoothly. As the title says, how can you test on Flutter? The first part is, can we start using Flutter? Over the last year or so, Flutter has become really hyped as a development tool for creating apps. And a lot of big companies are already starting to try that out and see if it has potential. But what does that mean for the normal developer who is in a normal small company that doesn't have unlimited budget to just try out all the new things? We really have to look at how a framework works and what are the strengths and what are the weaknesses. And one of the big parts of software development is, of course, can you test your software? And how do the tests run? Are they fast? Are they easy to create and maintain? So that's what we're going to look in this presentation. So if you choose a framework, you would want it to support testing out of the box. And of course, Flutter supports testing. On the main website, in the documentation, they show which kinds of tests they support. Of course, the unit tests, which are small, simple tests where you can test simple behavior of your code. They are easy to create. You create a lot of those tests. They run really fast. You don't really have that much maintenance on those. And they don't really have that many dependencies on the outside. But they do have a low confidence. So I think most developers, well, there should be a GIF about doors opening and infrared sensors opening other doors. Probably you'll have seen this image. Meaning, if you write a lot of unit tests and then that's it, that doesn't mean that your application will actually work correctly as you expect it to be. It just shows you that some of the logic behaves as it expected without any dependencies on the outside. So that's why they also have other tests. For instance, widget tests, which you can test separate components, UI components of your application without having to start up an entire app to test your UI, as is more common on Android. For instance, if you want to do UI tests, you probably use Espresso, and it means you have to boot up an emulator, maybe a fragment or an activity, and mock and stub all the dependencies, and that's a lot of code that you have to write, and it's also very slow. And most of the time, it can become very flaky if you have asynchronous things that you want to observe. And Flutter offers a kind of middle ground in that you can test separate widgets. And because the nature of Flutter is that it's written in Dart, Dart has a VM, so they can run entirely in the VM to test that code. And it's more like a unit test. So they should be really small if you make small components where you inject the state. They should also be easy to test. And they can be quite fast, but if you have a lot of complex widgets, they can also take some time to run. But they're in the middle ground in giving higher confidence, more dependencies, more maintenance, and slower execution. But they do show that the actual UI of your application does what you expect it to do. And then, of course, you have the integration test. That's actually starting up the device, starting the app, setting it into a certain state, and then finding elements on it, maybe interacting with it, and then checking if that is the correct behavior. But then again, those tests can become flaky depending on how you architecture your app. You might have to write a whole lot of boilerplate just to initialize a screen. So you would want to try to keep them as don't write that many of those integration tests versus the widget test and the unit tests. So I'm going to show you how in a Flutter project the unit tests run and look. So basically, if you have a project, you would have your application code in the lib folder. And then you have a test folder where you would put in your test code. And I've separated that in two different packages, one for the unit tests, one for the widgets, because then you also can run them separately, independently from them, each other. So this is basically a really simple calculator app. Don't mind the design. I am a developer, so let's see. It's building, but it should already be running. So it's basically a keypad with numbers and a few operators to do the calculation. And at the top, you can see the expression and the computation. And I have split that up into a block, which is kind of like a service or a view model or something that has the business logic without depending on any Flutter packages or anything on of the platform. And then I have a keypad widget, which basically is the keypad with all the numbers that you can press. And it calls into the block component to set the input, and then it calculates the value and puts it on the screen. So the block you can actually write as a unit test, and you don't have to depend on any other packages except for Dart, which makes it really fast. Basically, it starts the same way as the application would start. You have a main method which executes which gets started by the VM, and it then just calls methods. I've split them up a bit. You can create test methods directly, but you can also group them together if you have certain parts of logic that you want to test separately and make it a bit more logically structured. And as you can see, they're quite simple. We initialized the block and then just input some numbers and then expect if the value is what we expect it to be. And if you were to run this, they should all pass. And you see it took only less than 50 milliseconds to run all the tests. So if you write a lot of these unit tests, they still could be fairly fast in execution. You could, for instance, add a pre-commit hook or pre-push hook that would run your unit tests before pushing or committing on Git. And if you have like a really big project, you can even make it a bit smarter, like checking the Git status and then only running the tests on the changed files. And you should not really notice that in your work on developing the app. So how can we run those tests? There are different ways you can run those tests. You can run them from the IDE. So from Android Studio, IntelliJ, you can just execute them and you get a nice integration with the IDE itself. They have like the test window and they separate all the methods. You can just run one test method or one group or one file or the whole suite or anything in between. But of course, you can also run them entirely from the command line, which is easy if you want to write some scripts around it for the pre-commit hooks or maybe for CI integration. And basically, you just call Flutter with test and then pass in what you want to test. The normal directory is test, and then you can specify the actual file or an entire package or maybe even one test case in a test, and that just gets executed, and then you get the output in the console. So as I explained, you also have widget tests, which are also basically unit tests for your UI. And if you embrace the way Flutter tries to create UIs with small composable widgets, it will automatically also give you the ability to easily test those widgets. If you try to make really big and complex UIs and do that all in one class, for instance, it's also really hard to test. And if you force yourself to break those down in separate components, maybe even stateless components where you inject the state, they also become easy to test. So the Flutter framework actually helps you to make testable code if you really try to follow it. So I'll show the example of the widget test. So the actual widget test also lives in the test folder. Basically, it is almost identical to the unit test. Only in the unit test, we can depend on the package test, which is a Dart package. And in the widget test, we have to depend on the Flutter test package, which also contains the Dart test package. But it also gives you almost the same methods. You can group them. Instead of calling test, you call test widget, which passes you the widget tester. And it's an async method, which means that it's running asynchronously. So it takes a little bit more time than a normal unit test. Yeah. Yeah. So basically, you call a test widget. You pass in some description, so you know what you want to test. You get a method with the widget tester, and then you can actually create your own or initialize your own widget. Basically, I want to test the keypad widget, and that requires the block, which we can mock out entirely by using Mockito, and then we have don't have any dependencies. But you have to write a little bit of boilerplate code around it, because the keypad itself has an expanded widget, which means it needs to have a parent widget which has a flex base, so it can expand into the entirety of its parent. And the widget tester actually gives you a canvas, which is not really the same size as an actual device. I think the default is 600 by 800 pixels. So you have to wrap your own widget in a size box so it stays within that size. And if you don't really use that size, it shouldn't really matter because it's not the pixel perfect UI that you're testing, but just the interactions and the state you can test. But if you, for instance, check if it's this size screen, open this widget and else this widget, you might have to change the default parameters of the test. And then you can also test that. And you need to have a material app because we have the save area so that the keypad buttons don't overlap with the system UI for the home interaction or the status bar. So you probably can make this in a simple widget that you can have in your test package and then pass in the actual widget that you want to test. But for this test, I just wrote it in place. With the test widget you pump the widget, which actually generates the UI frame for you. And then you can call find methods to find actual elements in the screen based on text, for instance, or based on value or key or anything. And then you can extract on those. So in this case, it tries to find a text field with 7 and expects to find one widget. And the same for all the other text fields. We can also interact with the widget. So now we're telling the tester to tap on the button and then we pump, so time passes for it to render a new frame. And then we can verify the mock if actual the input is called for that button. And so you can verify that it actually also executes the code that you expect it to execute. And you can pretty much do anything you want here. If you do something with streams, it's probably going to be a little bit more code and a little bit difficult to go through the stream and have those things in sync. So it might be easier if you create a widget that in itself just gets a state, and you have a wrapper widget around it that either calls the set state or has a stream builder around it, which passes in the state. So you can test those separately versus trying to have to come up with a way of testing the entirety of the stream plus the interaction and the state of the widgets held within it. And if you run this one, you can just run it's run in less than a second. So even if you maybe make more complex widgets that take 2 seconds or 3 seconds to run, you can still write quite a lot of widgets before it actually becomes a longer process to run. And you can also always test specific widgets for specific methods versus the whole entire suite. Going back to how you can run those, it's basically entirely the same as the unit tests. They live in the same folder, and you can execute them the same way through the IDE or through the terminal. And those work pretty good, and you don't have to do a lot for that. Now that you have some tests, you probably want to check the code coverage for your application or your library to see how much you are testing. And that's actually pretty easy to do. You just add the parameter coverage to it, and it will generate a .info file for you, which has all the coverage information. It is not really directly readable as, for instance, a JUnit XML file. So if you want to read it locally, you have to generate an HTML report for it. But I think there are also services that you can push the info file directly to, and it knows how to extract the information. But if you generate an HTML report, it basically creates something like this, and you can see which classes you have and which codes is tested, which is not tested. And you can use this parameter to maybe say we accept the pull request because the code coverage doesn't go down or something like that. So now that you have testing and code coverage in your app, you probably want to have something that runs that automatically, a CI service. You could use probably any CI service that you know, Travis, Circle CI, name any, and it will probably run there, but you would have to create the configuration. Keep in mind that you probably want to build an iOS app, so you need to have a machine with Xcode installed and manage that entirely. For the Android side, you probably can make a simple script with a Docker image to just create an APK file. But for an iOS app, it's a little bit difficult. You have to manage the code signing and script it all the way. But there's luckily one service that is specifically made for Flutter, CodeMagic. So if you don't want to spend a lot of time on it, you can easily set it up. It works entirely through a web app. So you just hook up your repository to it, and it will automatically read all your repositories and tries to build them. Most of them are not Flutter projects, so I don't know why they are included. But they give you some configuration for it. Nowadays they even have their own YAML file, like all the other big CI services, to configure it. But you can set the build triggers, maybe set environmental variables if you want to run some scripts to upload somewhere or something like that. It does the caching for the dependencies. You can select how you want to test your application just by clicking a few check marks and it should run. I didn't get the enable Flutter test driver to work somehow, but it should automatically run if you read their documentation. They say we figured it out ourselves and then it should run. But for my project, somehow it doesn't work. You can select which device you want to use, iOS or Android. You can actually build the APK. Which version of Flutter do you want to use? What do you want to build for? If you just import the project, it automatically selects all the options. So it will even build a web version, a Mac and a Linux version for you if you don't have any platform dependencies. It's easily set which profile or debug mode you want to have. Maybe a different flavor of the application. And for publishing to the Play Store and the App Stores, how you want to do the code signing, you can just easily configure that here. For this app, I just get an email saying, hey, there's a new build. You can also integrate with other services like Slack, AWS. They even have their own static page where you can host your artifacts. Of course, you can integrate with Google Play and the App Store. That's also pretty easy to set up. If you've used to do this on your own, like have a plugin where you set all the variables and configure that, you probably know that it's a bit work to get that set up. And here it's actually pretty easy to do. Let's see if we can run a build. So I've prepared some changes. So basically it should start a new build now. Yeah. As you can see, there's a notification here that the new build has started. And then somewhere later we'll see if it's successful. So if you want to integrate with the CI, you can easily set it up. You don't have to have any knowledge about running your own CI machine or having hard configurations to manage. It's rather easy to do, but if you want to do it yourself, that's entirely possible. The entire Flutter project can be driven by the command line, so you can write your own scripts, integrate it with what you want. So that's not possible, but it might be a lot of work to manage that. But wait, there's more. Of course, if we build Android apps, we're used to running espresso tests. And on iOS, you have XKC UI tests, something that should also be able to run your app. But you might not want to do that for every situation. Maybe just a simple user flow that you want to have enabled, and all the edge cases you don't have to really test in the UI test. But we can easily write a test for that also. So for that, we need to add a different package called Flutter driver, which is a separate package. And basically, it works kind of the same like how the Android app does it with Espresso. You have the actual application that is being run and a separate app that drives the application itself. So here we have a main.dart for the application, where we say we want to enable the driver, which means underwater in the Dart VM, you can open it and see all the statuses, but you can also interact with it. That's how they do, for instance, the hot reload. They can push things to your app in the debug mode. So here we say that we want to enable that for the tests and then just run our application. And here we have the actual test file. Basically, it's also the same as the other tests. You can group your tests, and because these are a bit larger, you might want to make one group with some more tests. And this works also a little bit differently. Instead of trying to find things by text or by type, you would look at this by the value of the key of the widget, which means that normally when you create a widget, you don't really have to pass it a key. If you don't want to really control it, it gets automatically created for you. But there might be instances that you want to keep the key around so you can find it again. And for this UI tests, you need to actually specify your own key so that you know the value of it. And then in the integration test, you have to find that element by that key. So it isn't entirely black box as Espresso can be, because then you don't really have to know the contents or the structure of your application. And with this, it's tied together. But this also works quite similar. You have a setup method where you connect the driver to the application, a teardown method where you close the driver, and then you can run your tests. These are disabled because getText tries to find a text widget with the contents one, but actually we specify that the widget that we found is a button, and buttons don't have text, so these won't work. But for instance, the button that we found, we can tap and we can actually run this through, and then this should be the output of the calculation. And if we run that, it should actually start. Always nice when your emulator goes to sleep. It should start the same as you would expect from an Espresso test. Start the app, do some things, and then it passes or it fails. So it's quite fast. It does the tabs, and it passes because it found all the text that we specified. So let's see if the build that we just did finished, because all the tests have passed, and you can actually see the results of it. For instance, the testing, you can see the log output, but also a representation of how the tests were executed and grouped together. So you could also see which one failed or and for what reason they failed. We built an Android app and an iOS app. Then it published those by sending an email, and it cleans everything up for you. So if I refresh now, I have a new mail with a new app in it. And this basically all just click everything together, and it basically works. So it's not really rocket science. That was the presentation.